Hello, everybody, and welcome to Introduce a Girl to Engineering Day. My name is Madeline Berry, and I am so happy that you're here with us today. And today I'm going to be walking you through the electrical engineering portion, and specifically, we are going to focus on electromagnetism. So, first, just to note, there are all sorts of different branches of electrical engineering, and today we're going to focus on the topic of telecommunications. Telecommunications are the transmission of information by various types of technologies over wire, radio, optical, or other electromagnetic systems. So, first, what is electromagnetism? Well, electromagnetism is the combination of electricity and then magnetic forces that combine together and form electromagnetism. Specifically, we're going to focus on electromagnetic radiation. And so this form is a form of wave energy that exists all around us, even in space. This type of energy takes on as many different types of forms of waves, such as sunlight, radio waves, and microwaves. And these are just a few examples. Electromagnetic waves have a couple different types of attributes that make them unique. As you can see in this diagram, there are just a few parts labeled. As you can see, the crest and the trough, or the highest and lowest parts of the wave. The wave also contains a wavelength, which you can measure from crest to crest or trough to trough. Waves have an amplitude, or the distance measured tall that they are, and also they contain cycles, which are the amount of waves that pass through a specific point in a measure of time. And today, the two main that we are going to focus on that are very important for us is wavelength, which is measured by the Greek letter lambda, and frequency, F, which is measured in hertz, and 1 hertz is a cycle per second. Now, the electromagnetism, there is a certain spectrum to that. And as you can see on this graph, there are a couple different types of electromagnetic waves, such as gamma rays, X-rays, ultraviolet, visible light, infrared, microwaves, and radio waves. And as you can see, all of these have a very specific type of wavelength, some small and some long, and then they also have certain frequencies. Notice that the shorter the wavelength, the higher the frequency. And today we're going to focus on this tiny sliver of visible light. This tiny sliver is the only portion of light that we can actually see with our eyes. And so what is light? Let's focus on that for a moment. Well, it's a form of electromagnetic radiation, like we stated earlier, and it's comprised of photons, which are just particles of light. And they all contain the same wavelength properties we previously discussed. And so let's think about, what is the speed of light? You may have heard some about the speed of light, but why is it so important to us? First, the speed of light, which is represented with the letter c, is equal to 3 times 10 to the 10 power centimeters per second, or 3 with 10 zeros. That's a really big number. This is the fastest speed that anything can travel in our universe, and we as humans, we cannot travel that fast. We have not been able to produce anything that can even travel that fast. And so the speed of light is always a constant number everywhere in the universe, which makes it a very, very important number for us. And just for reference, if you could travel at the speed of light, you could travel around the Earth 7.5 times in just 1 second, which is really, really fast. Now, how can you calculate the speed of light? Well, there's a couple different ways. Specifically, one is using this formula. Lambda, the wavelength, times frequency, F, is equal to the speed of light, which is represented with the letter c. Now, how can you calculate the speed of light? First, there are a few requirements. You'll need a microwave, marshmallows, a ruler that can measure in centimeters, a calculator, and a pencil and paper. Now let's get on to the demo. Okay guys, first make sure you have all of your supplies, and that includes a bag of marshmallows, your calculator, a pencil and paper, and also a ruler. And make sure that it's a ruler that includes the measurement of centimeters. That's what we're going to be measuring in this demonstration. Next, arrange a tray of marshmallows in any sort of form. Okay, next, after you have your marshmallows in your tray, make sure to take out the plate that your food rotates on. This is very important for this demonstration. Okay, next, after you have your tray, make sure you place it in the microwave somewhere and then set the cook time to 25 seconds. Next, for this part, you might need to use your finger a little bit, but take your ruler and feel. There are certain spots where the marshmallows are really melted, and then some spots where they're more firm. So you're gonna take your ruler and measure in centimeters the distance between those melted spots and firm spots. Now, keep in mind, this distance is only half a wavelength. So whatever that distance is, you need to multiply by 2. Next, we need to get the frequency. Now we get the frequency by looking inside your microwave. Every microwave will contain a sticker like this with the frequency listed on it. It might be in a different spot on yours, but just open it up and look. And as you can see, my microwave frequency is 2450 megahertz. Now comes the calculation portion. So the distance that I measured between the melted and firm spots was 6 centimeters. Now I had to multiply that by 2 because that was only half a wavelength. So the full wavelength is 12 centimeters. And then I got the frequency from the sticker on my microwave, which was 2450 megahertz, which is 10 to the power of 6. Now also keep in mind that a hertz is the label 1 cycle per second. So now to calculate the speed of light, all you do is multiply the wavelength by the frequency. So let me enter 12 centimeters times 2450 times 10 to the power of 6, because that's the mega prefix, which is, I got 2.94 times 10 to the power of 10 centimeters per second. Now remember, the actual recorded speed of light is 3 times 10 to the 10 centimeters per second. So our number was very close. All right, everybody. I hope you guys enjoyed that demonstration, and I hope that you can also recreate that at home. But first, let's recap a little bit on what we learned. Let's talk about the big takeaways. First of all, electromagnetic waves exist all around us, and you use them every day, like when you go to heat up your food in your microwave. Radio and other communications devices use electromagnetic waves to operate. And also, the speed of light is such an important number for us because it's constant everywhere in the universe. Thank you so much, guys, for participating. I hope that you enjoyed your day. And if you'd like some additional resources, please reference the additional resources tab. Thanks so much.